Hello, and welcome back to part 6. And this is our final piece to the money manipulative. So we're going to just finish up our last segment with looking at ways that I could use money to help students visualize and learn their math facts. And then we're going to embed a few things into that learning of the math facts that give us other numbered outcomes at the same time. And then we'll finish up with patterning. So first off, at the very beginning of our series with money, there were a number of different virtual sites that I showed you that you could use to generate coins. And it's a real advantage, actually, if the students can actually see what 100 pennies look like. And that's exactly what we're seeing here is 100 pennies. And as we start to move forward with the group of students that we were working with before in grade 3, we initially started sort of with the traditional way of let's go 5 by 5 and let's get them to learn that before we move our math facts to 10 by 10. But we quickly learned that with the pennies, it was actually easier for them to see the groups of 10, and then we broke out our math facts from there. So whatever works for you, but starting with a 10 by 10 grid like this to show me 100 pennies is a great place to start. And what we actually did is we took these sheets and we put them into plastic pouches, plastic page protectors, so that we could just give them dry erase markers and then they could do the circling, the erase, whatever we wanted them to do. We also played something called the buy game. And the buy game was actually more generated by the students. But as we were teaching them how to start looking at these coins, and really it became a math talk to start with. What do you see? What do you think this is? What do you think we could do with this? So it's a great math talk opener. They quickly realized that there were 10 in each row. So again, we could also practice some subitizing, like what does 5 look like? 2 groups of 5. And we asked students, are you seeing 2 groups of 5 or did you see a whole row of 10? And it wasn't consistent. A lot of them saw 5s and 5s and made 10. They saw this as kind of a dividing line down the center, not that it was intentionally done that way, but that's what they saw. Others just saw it as 10s. So we could even make the connection here, depending on where you've started. We say that if this is 2 groups of 5, that's like saying I have 5 cents and 5 cents, or the same thing as I have 1 dime. So we actually put the nickels beside them or a dime so that they could see each row could represent 2 different coins other than the pennies in this particular case. Or if you've already had the conversation with them is what does that 10 represent as far as a unit fraction? Well, this is 1/10 of my dollar. So I need 10 dimes to get to $1 or 1 loonie. So this is 1/10. So there's my unit fraction conversation. So each row of these makes 1/10. So as they're learning their math facts, and if you have students in grades 5, 6, 7, 8, 9 that don't know their fractions and also don't know their math facts, well, then we can step right back again. So each one of these is 1/10, and those all have a common denominator already. So you're adding up like denominators to end up with 10 over 10 and have that conversation. So we can leverage this for wherever you see you need to start with your students. But let's just assume, and we know that not everybody's proficient at their math facts. Even in junior high, they don't all know them. So what are some ways that we can get them to start remembering and seeing them? And when we started working with the pennies with students, we looked at it from the array perspective. And we said, could you show us a 2 by 2? Can you show us a square? And can you just draw it in? So they would literally just do this. Now remember, they had a white cover on it. I'll go a dark marker here so you can see. That doesn't mean that was the only place. Some of them went a straight line. That's still an array. That's fine. But nonetheless, this is what we had. And we said, when you have a 2 by 2 like this, how many do you have in total? And they said 4. So we said, let's write that inside so we can see what 4 looks like. And maybe up here they went a single one, and we said, write 4 on top of that. But we're really trying to get them to start thinking about what those arrays could be in terms, in this case, we're using pennies, which is great because they're all a value of 1. We said, how does that change when it's a 3 by 2? Now, some of them were using different colors every time we gave them a new one, but they don't have to. A 3x2 looks like this. That gave me 6 of them in total. But a 3x2 could have also gone this way. So that could give me 6. So we asked them, to maximize the area, don't go right in the middle and muck everything out. Let's just sort of start at the bottom somewhere and just be consistent, or at the top and work your way down. So we said, let's find all the 2 buys that we could do. So a 2x2, a 3x2, a 4x2, a 5x2, and let's just see what you get. And eventually they say, well, that's just like skip counting by twos. Oh, okay, you're right. 2, 4, 6, 8, 10, right? So now we can get into that as well. And then we went into 3x3s, and then we went into 4x4s, and so on. And we did all those facts. And eventually they were just filling these in. But then it became a game for them. They would say, we have 2 minutes before the bell goes. Can we just play the buy game? And their idea was, how many of these could they fill in? So could they draw in the 4s? Could they draw in the 6? Could they draw in the 8? And they had to draw their rectangles. How many could they do in a minute or 30 seconds or whatever we gave them? Now remember, this was a buy game. These were arrays of something by something. We hadn't introduced the notion of multiplication yet. We were just working out different possible arrays. But by the time we started to expand those arrays and get bigger ones, and it was very evident that once we went to, when instead of going 3 by something, we often replace that word by with a multiplication, or we say 3 groups of 2. Can you show me 3 groups of 2? Well, here's 3 groups of 2 right here. 1, 2, 3. And they said that's 6. So without us really intentionally doing that, they had actually learned their math facts because they played this game so many times that they had learned their 4s, their 5s, their 6s, 6 groups of 4. They knew them just because they had been making them so many times. So it was one way that they just started to visualize that their multiplication facts were really just these boxes that they had been making. Now, could I start with a 5x5 if that works better for your class? Absolutely. You've got to do what works for you, and you've got to do it so that it fits where you see yourselves going and at what pace you're going to go. Can I skip count by 10s then? 10, 20, 30? Sure. Can I skip count by 5s? Sure. 5, 10, 15, 20. If I have something like this out too, and you have rec and recs in the school, you might want to get a rec and rec out and then show them how 5 whites and 5 reds are really the same thing as the top row of their pennies. So here's just another way for the money to equal another manipulative. It just is a way to transfer back to back. So then I can count by 5s on here. I could count by 5s on the rec and rec. 5 white, 5 red, 5 white, 5 red. So again, you're just transitioning so that they don't believe that a particular mode is only done with one particular manipulative. All right, so if I eventually get to 10 by 10, and yes, you're going to have to make it a 12 by 12 at some point, because when they get into grade 4, that's their mastery level is 12 by 12. Because of the game, we had students that went to 15 by 15, not because we expected that from them, but they just were having so much fun and they were mastering it so quickly that they asked for bigger ones. So we gave it to them, not that we were assessing 15 by 15 in any stretch of the imagination. So that's one way that I can leverage this. And then I might say to them, so over here, you told me that 3 by 2 is equal to 6. So what was a 10 by 10? What was an 11 by 11? What was a 12 by 12? So we can have that conversation. So now let's just take that one step further. Let me grab another sheet here. What if my question was with nickels? Now you're only seeing part of it because I photocopied them onto an 11 by 17, or I put them on there just because it makes them a little bit larger, and because the coin is a little bit larger, we want to be able to see it. So in this case, I've got my 5 by 5s, I've got another group of 5 by 5, another one down here. So I still have 100 nickels. So I can still say the same things. What are you seeing? Are you seeing a group of 10 or 2 groups of 5? And the way this is done, most of them see I see 2 groups of 5. Some students didn't say that. Some say I see 10. I see these 10. I see these 10. I see these 10. I see these 10. I see that row is a 10. So they're actually dividing them out at 10 and 10, so on. So they're going to see them all in different ways. Again, this would be a great math talk to start with. You put this up after you did the pennies and they go, oh, those aren't pennies anymore. Those are nickels. Yeah. So what do we see on this? What do you think we could do with this? What do you think that we can get represented by this? So now I could do the same thing. Can you show me a 3x2 in nickels? Sure, I can show you a 3x2 in nickels. It's right here. So there's my 3x2, 3x2. And that's going to be 6 coins, correct? Which it is, 6 coins. And I just asked them, how many coins do you have? 6. They already know that game. Now the question becomes, what's the value of those 6 coins? And then they'll look at you and say, what do you mean? I said, well, before we had pennies. And when we said, can you show me a 3x2? You wrote 6, but you said that was because you had 6 pennies. Oh, so I have 6 nickels. So some of them will skip count by 5. Some of them will know that 6 times 5. Oh, the value of this is 30. So now I can do a couple of other things, not just the array, not just what is 3 times 2, what is 2 times 3. Now I can say, what is 3 times 2? That gives me how many coins. So I'm going to craft my question carefully. How many coins is that? What's the value of those coins? And then we continue to bump that up within reason, right? You're not necessarily going to ask them 100 coins at 5 cents. And it's not unreasonable, but some students aren't going to necessarily know that large number right off the top of their heads. So that doesn't change with any of the coins. You can kind of see where I'm going in the sense that anything that I do at the penny can now be done with any of the coins. So here I have an entire set of dimes. So I could do the same thing. Can you show me a 4x5? So 4, well, actually it's 4 rows by 5, but I'm going to go this way. So this whole thing in here is 20 coins. And how much is 20 dimes worth? So that's my next question. So if I have 20 dimes, how much money do I have? So again, they can work that out. And I would continue to do that. Multiply, how many coins do you have? What's the value of the coins? So we would add those up to a reasonable amount. Keep in mind that they skip count by 2 5s and 10s in grade 1, and then they skip count by 20s, 25s, 50s, and 100s if they can in grade 2. So here's my quarters. And remember, you've got toonies that you can use, and you've got $20 bills and $50 bills that you can use for that skip counting. So here I can do quarters, and I'm going to be very careful how many I ask them the value of. But nonetheless, even if I said, show me a 4x3, okay, so I've got 12 of them in here. I might say, how much money do I have? And that's not an unreasonable question because they should be able to recognize that for every 4, I have $1. That goes back to my money on the number line. If I said, what unit fraction does one of these quarters represent of $1? Okay, that's what we did on a number line. Each quarter on $1 was 1 quarter. That was my unit fraction. Now it's not the unit fraction for 100 of them, but for $1, it was 1 quarter. So what if I said to them, well, if every quarter in $1 is 1 quarter as a unit fraction, what would your unit fraction be if you looked at these on a number line? How would you write that? So remember, you are now in grade 5, because in grade 5 is the only place that they start improper fractions. So this is 1, 2, 3, 4, 5, 6, 7, 8. I have 8 1 quarter jumps. How much money do I have? I will have $2, and they can figure that out. So there's so many different ways to use this money. It's not just tell me what the name of the coin is and what it's worth. We need to leverage that money for all the different things that we can do. And because money is so engaging to them, and actually, if you have enough for them to work in partners where they can just lay the money out and they can touch it with their fingers, you get way more feedback from them because they really enjoy that. The one that they can't lay out on their desk is the one that is the 50-cent piece. So those are ones where I'll just turn it so that the emblem is in the right direction. Those are ones that we would definitely run off for them and make sure that they are able to work with them here. So again, we could say for every 2 of these, what are you finding? So I would end up with $1 again. So what does each one of these represent from $1? The unit fraction of 1/2. And then I could do, can you show me 2 by 2? Can you show me a 3 by 2, a 4 by 2? And you could ask them, how many dollars do you have? This is an easy one for them to do. So again, these are values that we can look at of money, but also to leverage their math facts and figuring out what they have. So you might say to them, you know, why am I asking you this? Well, you might reach into your pocket and see that you have 7 dimes. So you need to know what 7 times 10 is. You need to know that if you had 7 quarters, that how much money do you have? So for every 4, you have $1. So what is that going to give me as a mixed fraction? $1, 3 and 3/4, or $1.75. Right? So that's that changing it from an improper fraction to a mixed fraction to a decimal, all on the same sort of number line lined up. One row is a decimal, one row is a improper fraction, one row is the mixed fraction. So they start to see the connections between what we're asking them and sort of the real world of what they might be putting their hand into their pocket and reaching out for. And it doesn't matter what age they're at. We can use all of these different monies to start things like patterns. So let me just grab these out of the way here. So if I'm a kindergarten student and I'm learning patterns, but I'm not quite sure yet about all of my names of my coins, I don't need to worry about that, because maybe what I'm going to do is I'm going to take, let's see if a light here will help. So if I put a loonie, and then I have a toonie, and then I have, let's say, a nickel, and then I start another one. So I have a loonie, I have a toonie, and I have a nickel. So depending on where they're starting, we might say to them, you know, what kind of a pattern do we see? So in kindergarten, they have to be able to name their coins. I see a loonie, I see a toonie, I see a nickel, I see a loonie, I see a toonie, I see a nickel, etc. And then once you get to a point where they're supposed to extend it, what would the next one be? And then we can say, can you come up with a pattern of your own that looks like this? So that means that they have 3 unique pieces in their core, and then it repeats the core again. Do they understand what the core is? Do they know how to find the core? And if they're older students, I even say to them, once you got the core, what's the value of your core? How much does a core equal? So I just know I'm doing mental math to get the money. This is the kind of back and forth. You don't have to just do one outcome. We ask them questions that engage them in whatever we've just set up for them, but then also go one step further and bring in another learner outcome that they need to know the values. And can they do that mentally in their heads? And can they name them? And once they've named them, can they tell you the value? You could say, can you tell me the pattern for the value? $1, $2, 5 cents, $1, $2, 5 cents. So just starting with that is enough just to get me going in kindergarten. You don't need to know everything. All I need to know is I'm going to start looking at patterns and colors and size. This one's much smaller. It's the same color. It's silver, but this one has gold in it. That's what they'll say. This one has 2 colors. This one only has 1, and this one's all silver. So that's how they're all different. So again, you can model the pattern. They create their own pattern and go from there. So we can use these in a lot of different ways. And the pattern does not have to just be with coins. Even at a kindergarten level, I could show them, and it might be as simple for them as I have a purple, I have a green, I have a blue. Now I can tell you that I know my colors, right? There's a starting point. I have a purple, a green, and a blue. Now, if they know that it's a 10, a 20, and a 5, great. If they know the names of them, if they don't, that doesn't matter. The fact is I have a purple, a green, and a blue. What would your next one be? A purple, a green, and a blue, and so on. Or I can take these, as we've done on some other final exams that we've been writing with students and teachers. We used, so there's my core. What would it look like if I repeated it? Now, I'm going to just mention that to you at the same time. When we're doing this kind of work, especially if you've got kids working together in different groups, we had students, we showed them or we asked them, we called it out. In fact, that's what we did. That's another way that you can check to see whether they know it. I would say, put out $10, put out a toonie, put out a loonie, put out another loonie, put out a $20 bill. okay, or $1, whichever way you're going to call it. So that way I'm calling it out. I'm not showing it to them. I'm not modeling it. I want them to see if they're grabbing the right ones. They could be working in groups of 2 or 3, and they can kind of work together on that. But what I was going to point out to you is if they are working in groups and we ask them what the core is, what we did hear from a number of students is I was sitting on this side. The core was a green, a dollar, a 2, and a 10, or a purple. But if I was sitting on this side, they saw it from this direction. So you really need to be aware that they may not see it from front and read from left to right. They're probably seeing it from the angle that they're sitting at. And in that respect, we didn't say they were incorrect. We just said, oh, so from where you're sitting, you're seeing that core to be this. And where you're sitting, you're seeing the core to be this. But if we were all sitting in the front, what would we all see as the core? So then we move it to that. But just be aware that happened a lot more than I was expecting, just because of where they were sitting on the floor. Or if you're sitting across from me and you're reading from left to right, you're reading this way, and I'm reading this way, right? So what is the core? So that's just some ideas that you can leverage for multiplication facts. You can do that with patterning for the students as they're working through, and using money for so many different things. Thanks very much for joining me in these 6 sessions, and I hope that helps use money in your classroom.